Hello friends, today we are going to see the fastest way to draw the beam, column and slab in ETABS. Also we are going to see how to define section properties and material properties. So kindly subscribe and like the channel. So here we started the model with our Indian standard provisions using the quick template for our today's model. So you can see the model has been created with the 4 grids in y and x direction, having story up to story 4, maximum height is 12 meters. So now we'll start with defining of the material. In that, first we'll start with the concrete as per region considered as India. Here we are taking as a default like M30 grade concrete. So all the specification of the M30 grade has been given from modulus of elasticity, Poisson's ratio, shear modulus, also the compressive strength. So these are the design properties for concrete material. FCK we know. We change you has to add, you can change in this data. So next one is the rebar material. We are considering HYSD 500 steel grade. All the design properties for rebar materials has been shown. So this is about defining the material properties for the model analysis. Now next phase is to define the section properties for beam and column. So we have to add new property and the section type is concrete rectangular. For any section property the material will be the concrete, whether it's a column and beam. So that's why we are selecting our material which we have defined earlier. So now here we'll define this section as a beam taking width 230 by 450. The section dimension, as you can see, the units are in mm. These units you can change to meter and as per your requirement. So here also other tabs are there, property modifiers and the reinforcement tab. In the reinforcement tab you can define the section property reinforcement data as per the requirement and having the set limits. So as this is the beam, we are considering this design tab as a beam, that is the M3 design only. Rubber material, here confinement bars we can use FE415. So we can define from here again the new material, keeping the covers as it is, no change. Calculate separately and give the values here also. So as you can see, the width and depth representation has been shown in the box diagram. Now next we have to define the column section. Procedure will be the same as for beam, starting with the concrete grade and taking the section shape as a rectangular. We'll take the section dimension as 300 by 450 and now we'll check the reinforcement data. Longitudinal bars HYSD 500, confinement bars HYSD 415. This you can define as yourself as per requirement. The material availability, the reinforcement check and design I will show at the last of the video. So these are the details which works when you are going to design the column, but for analysis these you can keep as default also. Check the reinforcement to be design option. So as per the SI unit or the common datasets you can define, and this all the confinement bars and longitudinal bars detail setting you can set to preliminary understanding of the design procedure. So now we'll give the property name which we define in the section dimension. It should not be vary because later we have to check the property by the property name for easy understanding. So now this property name section is done and you can see again the representation of the longitudinal bars which we define in the reinforcement data form. The representation is given in the box. Now we'll draw the columns, and you can see that this is the quick draw command we can use for the column. Just we have to drag the columns, and the grid intersection will consider as a column position, and the property which we have defined earlier has to be selected. Next is to draw the beam. Select the property of the beam which we have defined earlier. You can click one by one, or you can directly drag, and the grid lines will be considered as the beam position. Now you can see the beam and column has drawn, but you see it has drawn only on the story. It's a story 4. So we'll delete all the beams and column once, and we'll select the all story. Same procedure will follow which we followed earlier to draw the beams and columns, so that the beams and columns will be drawn at each floor. So in stories also you can define to work as individual story or all story, or you can define the story as a similar stories if the beams and columns are same for 2 or more than 2 stories. So after that you can see the columns and beams and drawn, and now you can see clearly after removing the horizon. Now we remain to draw the slabs. So we'll start with defining the slab properties. As you can see the slab property, and in that again the material will be concrete, so we are taking the N30 grade only. We'll take the slab thickness of 150 mm, and slab modeling type details about shell thin, shell thick membrane I will explain you in the coming videos. Now we'll select the quick draw floor option to draw the slabs quickly. So as we have selected the property of slab 150 of thickness which we have defined earlier, and we have to just drag the slabs as we have dragged for the beam, so that the whatever the grid box has been filled with the slabs. As you can see the slab has been drawn to the base also, which we don't want. This is due to we selected the all story option. Now we'll select the one story, and we'll delete the slab which has drawn on the base. Here base is considered as the foundation depth which you can give as per the geotechnical available data. That's why we have deleted the slabs. Now in this help option you can find the detail about the whatever we did, step by step procedure from defining to assigning the properties. Here all the steps are mentioned step by step, and as you can see they have mentioned the material property data, and as you can see in when the model starting there are some default material of steel and concrete which cannot be deleted. So you can define the property in isotropic and isotropic in the form which you like to define. So these are the steps which we have used for frame section property data to define section properties. Here you have to take care about the local axis and the global axis of the whatever property you are defining, and these options we explore while defining the reinforcement data form. So here you can see if you selected the column, we have to define all these properties. Here you will get to know when to check reinforcement to be checked, and when reinforcement to be design option to be used, and details about the longitudinal bars, confinement bars, and all other respective details. So thank you so much. So kindly like, share the video